With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hi, the question is, a violin player riding on a slow train plays 440 Hz note. So we have a violin player on the train who is playing 440 Hz note. Another violin player standing near the track plays the same note. Okay. When the two are close by and the train approaches the person on the ground, so the train approaches the person on the ground, he hears 4 beats per second. So the person on the track hears 4 beats per second. The speed of the sound in air is 340 meters per second. In the first part, we need to calculate the speed of the train, and in the second part, we need to calculate the beat frequency heard by the player in the train. Okay. So let's say we have situation like this. We have a train like this, and we have a violin player inside the train. We also have a violin player on the track, and this train is approaching this violin player on the track. They both are playing the same note of frequency 440 Hz. We need to find the speed of the train and the beat frequency heard by the player in the train. Okay, so before we solve this question, let us first discuss the key concept that we need to know to solve this question. So we know that when there is relative motion between the observer and the source of the sound, the frequency heard by the observer would be different, and it's called apparent frequency. And that frequency is original frequency times the velocity of sound in air plus velocity of the observer divided by velocity of sound in air minus velocity of the source of the sound. Velocity of the observer and velocity of source of the sound will be positive when object approaches the source or when the source approaches the observer. In other cases, they will be negative. Okay. Also, we know that the beat frequency denoted by n is mod of difference of two frequencies observed by the observer. Okay. So in the first part, we need to calculate the speed of the train. So let's say the train is approaching with some speed Vs. As for the observer on the track, train is the source of the sound. Okay, so we have taken the speed of the train as the speed of the source. Now we know that when the source is approaching the observer, the frequency increases. Okay, so the frequency heard by the observer on the track, let's call this as F, will be F naught, that is the original frequency of the violin player in the train, plus N. Okay, so from here we will get F, that is apparent frequency heard by the observer on the track, will be 440, that is original frequency, plus number of beats, which is 4. So it will be 440 plus 4. So from here we will get the apparent frequency observed by the observer, that will be 444 Hertz. Okay, now from the Doppler's equation, we can find the velocity of the source. As the observer is stationary, so the velocity will be 0. We have F naught, we have V, and we have F, so we can find Vs. So now from Doppler's equation, we have F equals F naught V plus V observer divided by V minus V source. Now F naught is 440, so this will be 440. Velocity of sound in air is given as 340 meters per second. So we'll substitute that 340. Observer on the track is stationary, so velocity will be 0, divided by 340 minus velocity of source. We need to find this, and the frequency, the apparent frequency observed by the observer is 444 Hertz. So this will be 444 Hertz. Now on rearranging, we will get 340 minus Vs is equals to 440 divided by 444 times 340, and from here we will get Vs equals 340 minus 440 divided by 444 times 340. Now on solving, we will get Vs as Vs equals 3.06 meters per second. So this is our answer for the first part. Now in the second part, or in the B part, we need to find the beat frequency heard by the player in the train. So for the player in the train, the two frequency heard by the player is the frequency of the violin he is playing and the frequency of the violin that this player is playing. Okay. Now for this observer or for this player, he is the source of the sound and the source is approaching, because in his reference this source is approaching towards him. Okay. So now the two frequency heard by this observer will be frequency of the violin he is playing and the frequency of the violin he is playing. Okay. So now to find the beat frequency, we first need to apparent frequency of the player on the track as observed by the player on the train. So let's call this as F dash. So that F dash will be F naught times V plus V observer divided by V minus V of source. Okay. So now we'll put all the values to find F dash. So F naught is 440 times velocity of sound in air is 340. So this will be 340. Now as the observer is approaching the source, so the velocity will be positive and that will be plus velocity of the observer. In our case, the observer is on the train, so velocity of observer will be velocity of train, which is 3.06. So this will be 3.06. This is in kilometers. Okay, divided by 340 minus velocity of source. As in our case, the source is the person on the track, so that source is stationary, so it will be 0. So from here we will get F dash as 443.96 Hertz. Now the beat frequency that we will get from here will be F naught minus F dash mod, and from here the beat frequency that we will get is 3.96, or this is approximately equals to 4 beats per second. So this is our answer for the B part. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.